this one. We're trying to solve this on 0 to 2 pi. Looks like that. You may say, oh my goodness, Professor, should I look for a triple angle formula? No. Can anyone give me an idea how on earth would you approach this one the way it looks? And not have to depend upon, in fact, I did not give you guys a triple angle formula to begin with.
Move the 1 over.
There you go, move the 1 over. Absolutely. And
It's 5 by 2.
divide by 2. This one's a little unique here. Now, as soon as it takes you down to something you recognize, now when I say recognize, it's this guy's recognition. Now you gotta come up with, where have you seen sine at this point equal to 1/2? Positive 1/2. And sine is positive, I think what's in quadrants 1 and 2? Can anyone tell me, in quadrant 1, what's the possibility?
Pi by 6.
Pi over 6?
Yep.
If I move to quadrant 2, another possibility I think is what, 5 pi over 6?
Yep.
So those are my possibilities for the unit circle. So that says when I go back, this, look at this right here. That 3 theta, no triple angle formula, equals pi over 6, to make that statement true above there. And I am going to write this as 2 pi, the period, just in case I need it. N number of times where n is an element of the integers. Or 3 theta could be representing 5 pi over 6. And I want more answers. It's 2 pi n for the period number for sine. Where n is an element of the integers. Now, does that make sense, guys, the way we approach it? Now, to finish this up, I'm gonna go back and divide by 3. Now, this is gonna be interesting. And it's going to give me here 3 substantial theta is equal to pi over 18 of all things, plus 2 pi over 3 n, where n is an element of the integers. That's called a general solution. The other one, divide by 3. And guys, if I do that here, you're going to end up with, of course, theta is equal to 5 pi over 18 plus 2 pi over 3 n, where n is an element of the integers. Nice problem. Now, I think though, I ask you guys to please express the answers caught within this interval, I think. Now, what does that mean to do now? Someone remind me what we had to do, which is a little lengthy. Those are general solutions. I'm going to write this word here. This is a general solution. And this is at this point, a general solution. Now what? How am I going to get the answers here? Does anyone recall what we had to do in class? Plug in, we usually start with 0. So let n be 0, let n be 1, let n be 2, and start listing as many as we can. And when I say as many as we can, guys, that fall within here. Now, by the way, I see an 18 going on here, looks like. I think. Is that true, guys? So now might say, okay, Professor, let's write this as 0 up to, what was that, 36 pi over 18 for the 2 pi. Now help me realize where I should stop. Okay, here goes. Let's see if it's going to work. Let's let n be 0. Now this is lengthy. If I let n be 0, that's the easiest one. This second term drops out, replacing n by 0 leaves me for an answer for theta. Pi over 18. Make room here. Now let's let n be 1. Let n be 1, guys, this becomes pi over 18. And I'll write right here. Pi over 18, substituting n with a 1 there, 2 pi over 3. Add those up with a common denominator of 18. I guess I need to multiply this by 6, 12. I think it's 13 pi over 18. Please, someone check and see if I'm correct. Okay? Now keep in mind, go up to 36. So you continue. Next one. See, I got them on the side here. Let theta be, then we'll let m be 0, 1, 2. If I put a 2 in there, in my general solution, this one looks like this, pi over 18 plus 2, 4 pi over 3. Common denominator to make this look a little better, 18. I'll multiply that by 6, that would be 25 pi over 18. It's like fractions. Let's hope I didn't make a mistake. I can go up to 36. See how lengthy this thing is? Okay, so we got this. I better do this. We got this. We have this one. And another possibility would be down, let n be 0, let n be 1. This one's let n be 2. Got all that done. Now let's let n be 3. Maybe we'll pick up another answer. We'll see. If n is 3, 3 should cancel. That's going to be 2 pi plus pi over 18, guys. My goodness, no matter how you look at it. I think it's going to be 37 pi over 18, I think. And which tells me in terms of the interval you have to work with, it's outside. So that means no, even though it does work, I can't use it. It's beyond the 36 pi over 18. So guys, right there is 1, 2, 3 answers. Now, Aaron, to save me a little time, I would have to do the same thing on this one. So I'm gonna find one of them. I bet there's 3 of these also. So before I leave this, if I let n be 0, on the other general solution, replace n by 0, that second term drops out and leaves me 5 pi over 18. And then of course you're supposed to let n be 1, n be 2, and I think when you do the calculation, you'll get 3 answers altogether for that one. I think there will be 6 solutions. I think altogether. And you guys can find the other solutions over there. You guys see how it works now? Okay. So be careful one of these. This would be lengthy if you see one like this. Very lengthy. Now, Sue was asking, I didn't show you, there is a formula for sine 3 theta. Like there's a formula for sine double theta. We know the double angle formulas. I know the one for sine double theta. She was asking, how about triple theta? There is one out there. I didn't show you what it looks like. You probably could derive one. Can someone tell me if, for an extra credit problem, I had on the final, write a formula for sine triple theta. In other words, create the formula yourself. Okay, and tell me how would you start? Because you've never seen me do it. Michael.
Split it up so it's sine 2 theta plus theta.
Beautiful. Look at this. Now he has something in mind here. 2 theta plus theta being very clever. That's 3 theta. Now I think Michael's telling me, and I should let him tell me. Michael, tell the class. Is this in the form of
That's not showing.
Is that in the form of sine A plus B?
Mm-hmm.
Is there a sine A plus B formula? Then you have to turn to that formula I gave you guys in class and finish this out. And you can actually create your own sine triple theta formula if you need it. Okay, guys? So I'll point that out. Now, I think, let me check. Yeah, that side's finished. Let's put the other part down here. Okay, part 5 says sketch 1 complete cycle of the graph of this. Now, I'm gonna do the best we can here. H of x has -4 sine. Inside there was pi root 4, subtract 2x. Now, before you sketch it, can anyone tell me how could I maybe clean up a little bit? What might you guys suggest I should do before I start graphing?
Isolate x.
Till we get.
Isolate x, like take away the -2.
I got you. Roberto, absolutely, look at that. Now, I will also even do this. Guys, we'll rearrange it, but he's already told me what to do. We'll rearrange those terms. Don't put the x term first, the -2x plus pi root 4. Then he says, wait, professor, you better get the x completely by itself by factoring out the -2. Now, be very careful. You're going to be left with pi over 8. Does it look like that? Okay. Now, Roberto, I noticed on that the work you turned in for extra credit, you and a few other students recognized something on one of those problems, which I think could be useful here. What, does anyone see something that could be useful at this point?
Sine is an odd.
Sine, oh, beautiful. Sine is an odd function, which means if I'm worried about that negative sign there, odd says, in essence, you move it out there. If it's cosine, which is even, you just get to merely drop it. This one, you move it out front, which is going to make that up to 4 now. Sine, the negative sign inside's gone. You're left with this. Oh, this is a nice problem. And now this is, if I have no mistake, in a simple form that I can deal with in terms of graphing. You guys agree? Okay. Now, let's do bounds. I'm gonna bound this like this. Let's see if you guys will agree. Between 0 and 2 pi. Here we go. Divide everything by 2. We end up with this. And if I have no mistake, we're gonna add pi over 8. Guys, I think you're gonna end up with 9 pi over 8 if I have no mistake there. Here. These are my bounds. Now, if you're gonna find the period, right now, even before you see the sketch, the period should be the ending subtract the beginning. So that's 9 pi over 8. Subtract pi over 8. I think we end up with 8 pi over 8. Or merely pi. There's your period. And from what we've done in class, I think I asked you guys to split this up into what? 4 equal parts? Like 4 quadrants? So your spacing, get this graph, would be to take pi divided by 4, well that's it, that's my spacing. Is that the way we approach these? Now see what that graph may look like. Okay, it's going to start with my bounds here. It's going to start at pi over 8. Right here. And it's going to end at 9 pi over 8. Down here. And I'm supposed to space by pi over 4, guys. Since I see those 8s floating around, let me rewrite my spacing number with this version, 2 pi over 8. The same as pi over 4. And I need to add 2 pi over 8, 2 pi over 8. I get 3 pi over 8, 5 pi over 8, 7 pi over 8, and finally 9 pi over 8. Nice. There is no vertical shift on this graph, so the only thing I need to worry about now is, it's a sine graph, so I have to know how the sine parent graph looked. And it's, down here. The reflection across the x-axis is gone now. So all I need is to stretch it by 4. Let's see if this will work. And here. And no shift going on. So guys, we'll start at pi over 8. This is based on this right here. It's a sine graph. What did the sine parent graph do at its beginning? Who recalls? At 0. It's on the axis. Right here. Now I think the next point, and I see no negative sign here to worry about. At the next point, I think it went up what? Up to 1. In my case, it's going to go up to or stretch by what? 4? Out here at 4. Then back on the axis. Drops down to a -4. Back on the axis. And looks like the shape might look something like this. You guys agree? And there's one cycle of that graph. The domain of the entire function, not just that one cycle, like this, is this. Range of my function, no matter what cycle you look at, looks like -4 up to +4. Period, we got it out of the way. If you want amplitude, I see the amplitude, guys, is 4. And that is nice. That is nice. Now, when you walk in Monday, I did a sine. It could be cosine. It could be secant. If those asymptotes or cosecant. I think you guys had a cosecant on the test on exam 5. Okay. Let's see what else we got here. That graph is done. Oh, I find the difference quotient. Michael the other day said, Professor, it's been so long since I've done the difference quotient, I've forgotten. Exactly what's going on here, Professor. Here, there's my function. I want to find this. All the difference quotient. Okay. F of x plus h, guys, this piece right here says go to the function, given up there, and replace those x's with x plus h. And you're going to end up with each one of those x's replaced. And mark this out to show I have done it. That's what that says. Then on top here, my difference quotient says don't stop there, subtract f of x on the end. Let me mark that out here. F of x, that's the original function. Just repeat it. And then don't stop there, divide everything by h. You guys agree? And then clean this up. Now when I clean this up, I'm going to end up with, I'm going to expand this out. X squared plus 2xh plus h squared minus x minus h. On the end, negative x squared plus x all over h. Simplify further, some of these terms will cancel. X squareds are gone. X's are gone. I have 3 terms remaining. They all 3 contain an h. No canceling. But I could take out an h for a common factor on top. 2x plus h minus 1 all over h, I think. And then the h's cancel. If I have no mistake, that is your difference quotient. Done. Pretty good? And now we're into, look at this. This is nice then. Now we're moving into material that we just recently talked about. Okay, so let me slow down just a little bit. Roberto, on this difference quotient in class, you know I like this one. That's a good illustration. It could be something like this though, so be careful. Where they may ask you to find the difference quotient. The square root, and you've got to be very, very, very careful, if that should happen. Okay guys, let's move into now recent material. Oh, this is recent. Okay, given, I give you a sequence. And that sequence terms look like this. And I'm asking to find, looks like it's A subscript 40, I guess. Is that 40? I think it is. A subscript 40. Find the value of the 40th term of that sequence. Now give me some input. How would you approach this? There's your sequence. I want the value of the 40th term. We need to come up with a formula. So there's a pattern here of some sort. Now that might be the tough part. I do see, and I think you see, at least I see as I examine these terms, there's a difference of 4. So somehow there's a formula involved here I could write that has a 4 involved. And does anyone think they know what I could write as A subscript n, that's like f of x. In terms of n, what would the formula look like knowing it has something to do with the 4? 4n minus 1? If it is 4n minus 1, definitely A subscript 1, replace n by 1, you get a 3. Replace n by 2, you get 7. N by 3, you get 11. It is going to work. Now, since I know the formula, A subscript 40, which is what I'm looking for, the 40th term, no problem. Looks like it's 160, subtract 1, 159, I guess. Figure it out. The next one I gave it as a recursive. They use the word recursive. I did not list the terms. I have it written like this. Now, this is one you got to be careful with. A little bit easier. Got to be a little careful with it. I gave it as, in the sequence, the first term has a value of 3. And then all of a sudden I give you a formula. A subscript n is equal to 2A subscript n minus 1 plus 1. And I'm asking you to write the first 3 terms of this sequence. And by the way, the first term is a gift. That's 3. Now let's try to find the second term, guys. The second term, with the help of the formula, that will be given to you. A subscript 2, that's my second term. Should be 2, A subscript 2 minus 1 plus 1, or 2, A subscript 1 plus 1. I gotta watch this myself. Of course, A subscript 1 was given to me as a 3, so I can make a substitution there. And if there's no mistake, I think it's 7. For the second term. Third term. If I use that recursive formula, A subscript 3 is equal to 2. A subscript 3 minus 1 plus 1. And this, of course, becomes 2. A subscript 2 plus 1. And I do that calculation. 2 and A subscript 2, guys, we just found to be a 7 plus 1, if there's no mistake, 15. Is that true? Okay. And of course, you can write out more terms. Okay, so sequences could be listed, the sequence could be listed term by term, or it could be a recursive type. The next one says find a summation. You gotta be careful on this one. Summation. And this one does not look that hard though. From 1 through 52. Here we go, 3K subtract 5. I would separate it. Guys, write this 3 as 3 placed out front. These were some formulas given to us in class, and I'm left with from k is equal to 1 to 52 of k. Which will work for me. And then subtract summation. Let's go from 1 to 52 of 5. Did I separate correctly? Yes, no? Okay. So we got 3, now please, can someone help me? 3, I need now, with your help, show what this means. Summation from 1 through 52 of k. How you gonna find it? Which means add 1 plus 2 plus 3 plus 4 plus 5, all the way through 52, and you can't take the time to do all that. It must be a formula.
52 times.
What was the formula? Does anyone recall the formula?
N times n plus 1 over
N
2.
times n plus 1 over 2, sort of like Gauss. N times n plus 1 over 2. Let me put that right here first. And Michael, since you gave that to me, we're gonna do this. That's a 3. Now if I use that formula, n in this case is 52, so you got 52 times 53 all over 2. Close that up. And that takes care of the first one. It says subtract from that this way. Now who remembers the formula that you need to recall to find this? This is one of the easier ones.
C times n.
Yeah, multiply C times N, which recognizes that in class, so it's 5 times 52. So that's solution. Guys, once you finish it up, the rest of this is merely arithmetic. Let me set that for you. Are we okay? Now, here's the problem, here's the issue. Michael, you got me out with this one? Yours on the exam, they have a k squared. And there's another formula to worry about. Is that true?
Okay.
What was it? N times n plus 1 times 2n plus 1 over 6? So it could happen like that. Now, with that said, let's see what else. Hey guys, I know you're taking some time here and you came in on your own today. I'm glad you're here, this should help. Oh, applications. A student was asking me the other day about this. She said, Professor, are you gonna have any word problems? If I do, it's gonna be one of those where they ask you to find the maximum height of a ball being tossed in the air, where you use negative b over 2a, or like a fencing type problem, like I think we were doing a fencing along Pico in the example. It could be one of those, if you have an application. Oh, we're about to finish up here. Now, part 9, find the exact value of, here goes, tan of 22 pi over 3. Who recalls? And this is sort of recent. By the tan of 22 pi over 3. How do we approach this? Yes?
Divide 22 pi by
I would, thank you. Divide this out. 3 into 22 pi, out of 7 pi, 21 pi, you have pi left over, looks like that. And that will help you to determine which of the 4 quadrants is the same we're located. Guys, the illustration says move 7 pi. Well, that's 2 pi there. Another 2 pi, another 2 pi. So you make 3 complete revolutions, and then an additional pi with 7 pi eventually land here as you move. And then from there, move an additional 60 degrees, or pi to 3. You're going to end up in quadrant 3, if I had no mistake. And I know everything down there is negative. Are we in quadrant 3? Are we, guys? someone check? Okay. So I'm in quadrant 3, tan down in quadrant 3, y over x, negative over negative. I know the answer must be positive. That's why that quadrant was important. So y over x is positive. I want tan, so therefore I need a reference angle. Well, I see the reference angle. Now I gotta give you something that you can work with from that unit circle on the test. In other words, I can't give you a pi over 5 or pi over 9. So it's something you recognize. Guys, pi over 3 is on that unit circle. The coordinates for pi over 3, help me out. Is it 1/2 radical 3 over 2? Yes or no? Okay. I want tan. Tan says y over x. So that's radical 3 over 2 over 1/2. 2's will cancel. Looks like that's the answer. Yes or no? Okay. The next one says simplify this expression. Here goes. You got 1 plus cosecant x over cosine x plus cotangent x. So they want you to do what you gotta do and try to simplify this. So guys, what it comes down to is I need some replacements. Let's write this as 1 plus, does anyone have in mind a nice replacement for cosecant? What's cosecant equal to? That I could use maybe. 1 over sine. Absolutely. And then when I move on down to my denominator, I'm gonna leave cosine the way it is. But I do see on the end there cotangent. Guys, what's a nice replacement for cotangent? Anyone?
Cosine x.
Cosine over sine?
Uh-huh.
Okay. And now those are my replacements. Everything's in terms of sine and cosine, which is good. Now to clean this up, I need to put those two terms on top together with a common denominator of sine x. No problem. Sine x plus 1 over sine x. I combine the two on top with a common denominator. Downstairs, down here, I'm going to put those two together with a common denominator of sine x. That's going to look a little strange. Sine x, cosine x, plus cosine x, all over a common denominator of sine x. Did we do that correctly? You know and I know when you start simplifying this, those two will cancel. Now I got sine x plus 1, something unusual is going to happen here. I love this problem. Sine x plus 1 over, does anyone see anything I could do with the remaining part down here?
Take out the cosines.
Do it again.
Take out the cosines. So
Take out the cosine. Factor out a cosine. Look at this. And he's telling me if I factor out a cosine, I'm left with sine x plus 1. Now that is nothing but cute. These will now cancel. Guys, I'm left with 1 over cosine x. And what's a good name for 1 over cosine x? Don't scare me. What's 1 over cosine? Secant. All this comes down to secant. And there's your answer. All this mess is named the secant. Okay, so make sure you understand how to simplify something like that. Find the exact value of sine 15 degrees. And sine 15 degrees, guys, I need a formula. And here's a choice. I've seen some students express 15 degrees as 1/2 of 30, which it is, and they use a half angle formula. I've seen others say, Professor, I prefer sine 15 degrees, not 1/2 of 30, but maybe sine of this. 45, subtract 30. Guys, therefore, if I do it, if I do it like that, I'm into a what, A minus B formula? So here goes. And you have to know what the sine A minus B formula is. Sine A cosine B minus cosine A sine B. I think. Okay, here goes. So I'm looking for sine 45 degrees. I'm gonna put pi before, guys. Cosine of 30 degrees, pi over 6. Subtract cosine pi over 4, sine pi over 6. Are we good? I hope. This has got to come from the unit circle. Sine of pi over 4 is radical 2 over 2. My goodness, we all know that. Cosine of 30 degrees is radical 3 over 2, I think, from the unit circle. Cosine of pi over 4, another radical 2 over 2. Sine of pi over 6, 1/2. So you got radical 6 over 4 minus radical 2 over 4. Better yet, radical 6 subtract radical 2 all over 4. I hope we don't have a mistake. Is that reasonable? Does it look reasonable? Now, let's say a clever student says, no, professor, I would prefer to do it like this. I'm going to set it up for you. I prefer to think of it as sine of 1/2 of 30. That's 15 degrees. Then now you have to turn to sine 1/2 angle formula. And we look quite much different, we look a lot different than what I have. But after you estimate it, it's actually the same. You guys, you could use this also. I'll let you look at that if you wish. Oh, the last one here. Okay, evaluate. Guys, remind me, have I really, have we worked all these? We didn't leave anything out, did we? Okay. So let's find the value for cosine. 2 inverse tan 5/12. Okay. Now, can anyone tell me? I'm gonna approach this 2 different ways. Leave it up to you as to how you want to approach it, unless I specify in my directions. Can anyone though tell me how would you start? Or can anyone tell me the way this thing looks, which formula do you think you're going to rely upon at the end to get the final answer? Just the way it looks right now.
Double angle
A
cosine.
double angle formula, cosine double theta. So eventually, I'm going to end up with this. And guys, the cosine double theta, darn it, that's the one that has 3 versions. First one I think was what? Cosine squared, was it? Minus sine squared. I think there's another one, 1 minus, let me mess this up. 2 cosine squared. And I think there's 1, 2 sine squared minus 1. So eventually I'm going to rely upon that, or one of those to finish up. Did I have those written correctly, guys? Yes? No?
Sure, 1 minus 2
Yeah, I'm looking.
sine squared.
Oh, you're 1 minus 2 sine squared? Look at it now. Is that written correctly or not? Oh boy. Now, how will I check to make sure? if we know this one, this is the main one, cosine squared minus sine squared, you said, Professor, suppose I have so much to memorize as it is, I've forgotten. I could easily replace this with this. Sine squared plus cosine squared is equal to 1. Guys, could I replace that sine squared in the first version with 1 minus cosine squared? And then clean it up, would I end up with, look at this, would I end up with what for the second version? Maybe that's what I wanted to do. What would I end up with here? If I actually replace sine squared with 1 minus cosine squared. Would that give me 2 cosine squared minus 1? Is that it? Is that true? Now, you'll say, Professor, how about this one? I've got so much to memorize, Professor, maybe I'm gonna mess up. Now, suppose you go up here and say, no, I'd like to replace this one with 1 minus sine squared in the original. What will that give me, guys, if I replace this with 1 minus sine squared and got another minus sine squared? Is that gonna be 1 minus 2 sine squared? So that could give me, now I want to do that, make sure, just in case you have to derive or find it. It'll give me this. Do we now have all 3 versions? Okay, so it might come out to be this version to finish up that problem. It might be better to use this version. It might be better to use this one. Okay, let's see what it's going to be here. Guys, inverse tan, 5/12. Says there's an angle out there, here's the translation, whose tan is 5/12. It's not one of those that we know by the unit circle, but that's what it means. The angle has